Thank you, Ryan. All right, so hello everyone. Thank you for joining our first ever Rice Recent Grads in Aerospace panel. We're really excited to have you all here. Really excited to have all these panelists here. So just as a quick formatting item, just in terms of how we're gonna do this. So I'm gonna moderate the panel. I have some pre-prepared questions that I'm just gonna go through to kind of keep the conversation going. But ultimately, this is kind of what all of y'all wanna ask our panelists about just their experiences, how they got into the aerospace industry, what their life has been like so far. It's sort of focused mostly on your Q&A. So if you have any questions at all, go ahead and type them in the chat. They can be directed to all the panelists or a specific one, and then I'll sort of go ahead and answer the questions as they come in, and sort of jump back and forth between the questions I have and the ones that you want to ask. And then once we get to a question, I'll call on you so you can unmute yourself and ask the question. And yeah, it's like I said, it's mostly focused on your questions. So like, please ask anything, ask away. Yeah, so hopefully it'll be a bit of an interactive panel as well. So with that, I just guess I want to start off and ask to have all of our panelists just give themselves a brief introduction, just who they are, when they went to Rice and what they do now. So Alejandro, can you start first?
Sure thing. Well, hello, I'm Alejandro. Luckily, I think I've met most of you, or at least some of you here, so nice to see some familiar names. I am the most recent graduate from at least this panel. I graduated just a few months ago in May. I was in Brown College, mechanical engineering. I also did the certificate of engineering leadership. So those are basically like the main focuses that I had on the academic side of things. As far as more extracurricular things, I was very involved in Rice Eclipse. I was very involved in RCell. I was involved in SEDS, and then I kind of jumped around in some other organizations as well, but those were kind of my main focuses. And yeah, I'm currently working for Lockheed Martin as a manufacturing engineer. I work in the space headquarters here in Denver, and I mostly work on deep exploration satellites as well as some military support programs. Those I can't really talk about, so I'll focus on the deep exploration one. So I touch things more like Orion. Currently working on a satellite called Lucy that's going to be launching hopefully next year to explore some Trojan asteroids over in basically Jupiter's orbit. And I work mostly on mechanisms, so mechanism assemblies, and I do a lot of work instructions, a lot of basically on the fly, solving issues on the floor at all times. I communicate with a lot of different people, a lot of like engineering communication skills, very much necessary for that kind of job. And yeah, I'm loving it. So I also love mentoring students and helping out. I've already had a couple people that I've been talking to for the past like month or so. So I love talking to students about things to help you guys get to where you need to be, because I know I needed the help, so I'm happy to provide that as well.
Awesome. Gigi, want to go next?
All right. Hi, everyone. I'm Gigi Rill, and you're all making me feel a little bit old because I don't recognize, I've probably met some of you, but yeah, I only graduated in 2019, so I've only been up for, a year and a half, but, time flies once you're out. While I was at Rice, mechanical engineer, Martell College, I also did the design minor as well as the Rice RCell certificate and the leadership certificate. Extracurriculars I was president of Rice Electric Vehicle, did a lot of work on that. I did some extra projects in the OX, so I actually took like NG120 projects and took it all the way to completion. Ended up delivering it to the end user, so that was really fun. But probably the thing I was the most known for is I was head of the Martell beer bike build. So if any of you guys came through or were here for either, let's see, would have been the Ciderman, so the upside down Ciderman room, or the, I guess we didn't have it last year, or the, I'm forgetting about it. Anyway, I did all the Martell beer bike builds, and so that was really fun. So as far as what I'm doing now, I'm now working for Boeing. I'm in St. Louis. I'm working on the defense side. So pretty much what I'm doing right now is I'm in a rotational program. which basically means that for the first 2 years I work for Boeing. I switch jobs every 6 months. So I'm going to switch jobs to different business units as well as different areas of the life cycle. So I started out when my first rotation was with their research and technology field, specifically doing what we call the teardown lab. It's kind of a reverse engineering, but of our own parts, focusing a lot on, okay, what's really driving cost in these designs? You'll have something like, you'll see a design that we've had for 30 years, and it's using a connector that's no longer made. And so you might be saying, okay, this one connector is driving cost because this one connector is no longer made, so it's costing $2,000 for this one connector, when we can not only upgrade for performance, but we can upgrade to have it be a cheaper cost. And so really doing some really in-depth look on, okay, how do we actually make our parts smarter as far as cost goes? My second rotation was I was on the F-15EX training simulator. So as a systems engineer, came from a mechanical engineering background, knew some stuff about planes, but I wasn't an aerospace major. And so I went from I knew the very basics of planes to I had to learn absolutely everything there was to know about an F-15 in about 3 months. And that was really fun because I got to do, on the systems engineering side, it's called SEDS, so Systems Engineering Integration and Test, CIT. So the integration and test side was really fun because it'd be like, okay, so the coders would enter in something that says, hey, we've modeled this tailhook simulator. Okay, well now you have to go hop in the simulator and fly it and go try to catch the tailhook and see if you're actually catching it where you think you're supposed to be catching it, that kind of stuff. So that was super fun. And I've been doing that, and I did that from January to July. And then since July, I've been in the Things and Stuff division. And similar to Alejandro, we're not going to talk about that.
All right, awesome. Ina, want to go next?
Yeah. Hey, is my mic working okay? Because other people want to check.
I can hear you okay.
Coming through? Okay, great. So my name is Nana. I went to college and I'm a chemical engineer, and for extracurriculars, I was pretty involved in Habitat for Humanity, and then AICHE, which is the Chemical Engineering Society. And then I actually took a gap year my junior year, or right after my junior year, and joined the Pathways program at NASA. And that was really, really cool because you want to while you're there. So the battery group, and batteries are going to be replacing the batteries on station because they're lithium ion and rechargeable. We were testing just when they go into thermal runaway, how much heat do they give off, and how do you design be safer so that you don't have a fire on station. So that was one really cool project. And then the next one, I went to ISRU, which is In Situ Resource Utilization, and that's where I work currently. And basically, we're trying to figure out how to make resources on the moon and Mars so that people can survive there for long duration. And that's really, really neat because we're trying to figure out how can we use the oxygen from the soil or the water ice that's at the South Poles, and how can we use that to make rocket fuel. So it's really neat, very research oriented. And then my last rotation was in the thermal systems group, and they're trying to make advanced technology for long duration missions as well. So they're struggling with creating heat exchangers that don't have biofilm growth on them. And so I got to work with microbiologists on that and test out new hardware. So it's very hands-on. And I've gotten to do a lot of, I'm a chemical engineer, so I've gotten to learn a lot of mechanical and electrical. I didn't have before an instrument as part of the larger instrument package called WAVE, and it essentially has all these different robotic mechanisms that it collects lunar dirt and then weighs it and seals it and heats it up and drives off the water, and then it measures what the content of the water water and gas in that sample was. So it's really neat. We get to work with a lot of different groups, and yeah, hopefully we'll get to fly it. So very hands-on.
Awesome. All right, so we'll go into the first question now. So you all kind of touched on this a little bit, but can you share a little bit just about what your day-to-day life is like at work, just what like a typical day at work is for you? Is it like mostly technical design and analysis, or do you find yourself in project management roles, or there's kind of a big gap between what we as engineering students experience in school versus what y'all actually do in the real world. So just kind of share a little bit of like a slice of life at work.
Sure. I think of manufacturing engineering as a people person job. It very much is not as crazy, like focused and technical as some of the other roles that you would find in an engineering company. It really revolves a lot more about being reactionary, being focused on scheduling, being focused on cost, being focused on performance and things like that. So, you know, I have a cubicle, but I only spend maybe like half my time in it. I'm pretty much expected to spend half my time in my cubicle doing, you know, computer work, and spending the other half on the actual floor in the lab with our technicians working on the hardware itself. So it's kind of cool because a lot of engineers don't actually get to see the final hardware that they're, you know, working to build. And manufacturing engineers do, because you work directly, like you're that thread basically between the design engineers, the systems engineers, the test engineers, and then the actual technicians on the floor. So it's very much, my job very much revolves around, you know, can we pull all these threads together and make sure that work is being done in the best way possible, addressing any issues that come up. So like an example of like a typical day for me would be, you know, I have a scheduling meeting every single day at 8 in the morning. So we hop on a call, we talk to the actual mechanical engineers who have designed the stuff that we're working on. We talk to the technicians that are currently working on it. We talk to the supervisors that are doing more like the scheduling and the project management stuff. And we basically talk about, okay, how are things going? We basically call it a daily tag up of just how is the progress going? What did we get done? What did we not get done? If there's any quality issues that happen on the floor, we tag those, and those have to be resolved by the actual mechanical engineers, or, you know, depending on what kind of issue it is, it might require some sort of authorization before we move forward to it. But basically, the moment that we determine the root cause of a problem, it's my job to then translate that into an actual solution and deliver it to the floor so they can do whatever needs to be fixed. So it's very much about being able to solve problems at all times, knowing all the resources, and kind of funneling all of those things into actually getting the work done on the floor. Like we basically support the technicians because they're the ones that actually make us money, right? They're the ones that actually build the hardware. So we support them, and at the same time, we support every single other faction that has an investment in that hardware. So that's generally how I like to think about it.
Awesome. Do you want, I guess we'll just go Alejandro, Gigi, and Nana for the questions, unless y'all want to jump in early. But Gigi, do you want to go next?
Yeah, I'll go next. And I'll talk about my last rotation where I was a systems engineer. I know that that's kind of a term that is thrown around a lot at Rice, and people don't generally know what systems engineering does. So I can talk a bit about that. Systems engineering, so I mentioned SEDS before, right? Systems engineering, integration, and test. But particularly on like the software side. So one thing is that particularly the US Air Force is really pushing this agile framework. So if you don't know what agile is, it's basically, it's a concept of, instead of having, you know, a massive code, you create a massive code, you deliver it to the customer, and then the customer doesn't really like it. Instead of doing like a big project, it's small continuous deliverables. That way you're getting feedback and you're doing kind of a more iterative process faster. So as the systems engineer, I wasn't doing coding, but I was working in that agile framework. And what's kind of unique about agile is basically you have what are called 2-week sprints. And so at the beginning of 2 weeks, you say, okay, this is what I think I could get done in 2 weeks. And at the end of 2 weeks, I'm going to have these, 5 things done. and you only commit to what you think you can accomplish. And you say, at the end of 2 weeks, I'm going to have, you know, code for this piece, and this piece done. And I could demonstrate at the end of my 2 weeks that I did these different points. So that's on like the kind of software side. The systems engineering side kind of pairs with that to really do the more requirements writing, right? So when you're doing a problem set and someone gives you, hey, you have, you know, a certain, you know, RPMs that you need to hit, or your radius needs to be this big, or stuff like that. Those are all the requirements that are given in a problem set. However, in the real world, there are no problem sets. So, and oftentimes you'll have very, very vague requirements given from the customer. So the customer will say something like, I want this weapon to work on the aircraft. And you're like, cool. What does that even mean? Are you talking about where does this weapon go, right? You can't put really heavy weapons on the X2, like on the tips of your wings, because if you think about it, when you turn your plane, you know, you're gonna have just crazy stresses on your wings. So there's only certain locations it can go. There are certain deployments it can do. You know, when that weapon is deployed, you know, what does that look like, right? Are you gonna just go straight forward? Are you gonna go straight forward and down? What's gonna happen? So in the broadest terms, systems engineering is kind of interpreting the customer conversation of, you know, we want clouds in the simulator. And I say, okay, well, why do you want clouds, right? Do you want clouds because what training behaviors are you trying to get at? Are you trying to get at, you see a thunderstorm and you fly around it, you want to fly through the thunderstorm, you just want clouds because it's going to look pretty. But really understanding that and putting that into distinct terms that the coders can then go code to. If I say, hey, I want a thunderstorm that goes from this elevation to this elevation, you know, this is the visibility ranges we want in there, you know, stuff like that. So that's kind of the systems engineering side. And then see it the other side. So you have the systems requirements, then they go code, and then on the tail end of that, I go verify that the code fits my requirements. So if I say you should be able to code a thunderstorm from 10,000 feet to 2,000 feet, I would basically send that off to the coders, they go code that, and then it comes back to me, and then I go fly in the simulator, and I fly at 10,000 feet. And if I'm at 10,000 feet plus one, and I don't see clouds, and I'm at 10,000, you know, 9,999 feet, and I don't see clouds, then they fail, right? So it's defining those requirements. And I particularly really liked it for the simulator because you kind of got to touch on all kinds of different features and activities. And I worked a lot with former fighter pilots. I pretty much hung out with former fighter pilots, and they taught me how to fly in the simulator, and that was my job. So it's very cool.
Cool. Yeah, that actually, some of what we do is also requirements definition and just propping up the architecture. Because it's a very new, and we've been kind of shifting back from moon at NASA, so it's been like 10 years since we worked on this on the moon. So just figuring out all the technologies that we've invested in and which of those would work well together, which of those have the least power draw, the least mass, which ones are most reliable, and have the highest TRL. One, we're trying to figure out which commercial or which technologies that we can use. The other thing, developing our own technologies that we can and competing with each other. But yeah, so the first part is kind of the architecture definement, and then just looking into research papers and figuring out, hey, there are these different contaminants in lunar ice, and which one of these do we need to be concerned about? How do we get rid of them? What are the different technologies that we can use? So that's, as a chemie, that's been a big part of my role recently. And just working with the different companies and figuring out how best to test their technologies in a way that we think will be useful for us. So that's one part of the job. And then the other part is very experiment design based and mechanical design based. And so it's a little bit of everything. Yeah, you're working in Creo and doing CAD design, you're doing analysis, your different factored, and you work with the testing group on site and figure out like, hey, I need to get it to this next TRL level. What do I need to test? Do I need a vacuum chamber? Do I need really cold temperatures? And just working with the testing group out there. And then, so for example, on oven, on the instrument, we have a bunch of different motors. And one of the tests was to see if we can cycle them and have them work at the colder temperatures and the hotter temperatures. And then we have to do analysis of those results and figure out if we need to resize those motors and redesign the instrument. So it's a little bit of everything, which is really cool.
Awesome. All right. So going on to the next question here, could you share just what experiences you feel from your time at Rice best prepared you for the work you do now? It could be technical or non-technical. Just, what should we as Rice students now be thinking about or try and be sort of doing more of to prepare ourselves for careers in the industry?
Oh man, yeah, that's kind of a big question, huh? Honestly, I can say by far, and this might be controversial to say, but I don't think it actually is. My extracurriculars prepared me way more than my academics could have. That might also be just partially because of the role that I'm in. Manufacturing engineers, I'm not using MATLAB all the time. I'm not doing some sort of like crazy stress simulations or anything like that. So it's more particular to my role. But the experience that I gained through my extracurriculars at Rice really, really, really prepared me for the exact kind of work that I do. Not gonna lie, Rice Eclipse does a really good job of trying to get you as close as possible within, a student budget and student experience level to what a real world engineering job could look like, basically. So, you guys said, at least within Eclipse, and I know SEDS also, whenever I worked in the CubeSat project with SEDS, that's also what we were trying to get to. I'm sure you guys are probably heading that way as well, if not already there. But, trying to understand what it takes to collaborate with other people is huge. I give Rice a lot of props for trying to make the environment as collaborative as possible within academics. I know a lot of other schools have bad reps because, maybe things tend to be pretty heated or very much like student versus student rivalries. But Rice tends to be pretty open and collaborative. But honestly, being in like those actual engineering teams, whether it comes to designing a satellite or designing an engine or designing an airframe or even, a senior design engineering design work, anything that has to do with team-based engineering projects is by far the best. I kid you not, whenever I had my interview for Lockheed, I got the call for the offer the next morning, and literally the reason that the manager told me that they wanted to give me the job is because they can teach someone the technical aspects of a job, and they expect to teach you the technical aspects of a job, but they can't teach you how to be a good teammate. Like, that's just not, they can't afford to teach you how to be just like a good teamwork oriented person. That's something that they need you to already come with. And then it's true, like whenever I'm anything that I do at work right now, like I can't imagine it being a part of an academic curriculum, but the kinds of skills of just being able to interact with other students, being able to work, being able to be a good leader, being able to listen well, being able to to resolve conflict, all of those skills are huge. And the better you can be at them and the better that you can get practice now, the better you'll look. So I think that's definitely what prepared me the most for this role. And I think, honestly, it doesn't just apply to manufacturing engineering. I think those are all kind of essential skills that you need to have regardless of where you go in engineering.
Yeah, I would say I agree a lot with Alejandro. I mean, it's one of these things where your classwork is going to be important, and knowing what you're going to learn in the classroom is important. But a lot of what you're going to get, or a lot of what you're going to take out of the Rice experience, is going to be more about outside the classroom than inside the classroom. And what I mean by this is, if my number one piece of advice for people, particularly for young engineers coming into the workforce or people coming out of college, I want you to think back of when you came into college and how everything you did in high school didn't matter after about 6 months, right? Nobody wanted to hear about all the great projects you did in high school. Nobody was so impressed about your SAT score. And like, those were all very important things, and they got you to where you are. But nobody's going to care about that after about 6 months. And so what I kind of recommend for you guys in your position, what you do at Rice, particularly like the extracurriculars and stuff like that, that Alejandro mentioned, that's going to get you an interview, that's going to get you a job offer, but really what you're looking for is those transferable skills. And what I mean by transferable skills is you need to learn how to build credibility. Now, this is something you've probably already done at Rice or are working through at Rice, because you came in, from high school, probably all really high performing people, excellent grades, stuff like that. But you hit a certain point at Rice where you're like, wow, what worked for me in high school did not work for me now, right? And so really learning to build that credibility. If I'm going to say, hey, I'm a structural strength engineer, or, I did this analysis and it's right, and you can go fly an airplane based off the analysis that I did, you need people to believe you. And so learning to build that credibility, right? It doesn't matter. It doesn't matter what you learn so much as how you learn it in college, right? So it's going to be a lot less of, hey, I took a class on, dynamics, and now I can go design, rockets or whatever. It's like, no, okay, you're going to learn those technical skills. So kind of, credibility is two parts. So one is humility, right? Don't come in, thinking that you know everything. You're like, oh, I went to Rice, I'm so smart. So don't come in, be willing to learn, right? There's a humility, particularly in the aerospace field. I mean, there are people here that have spent 40 years in this industry, and they're going to know a heck of a lot more than you. So there's kind of a level of humility, and then there's also a level of eagerness to learn. So making the fastest way to build credibility is to really just dive in. Whenever I join a new team, because I'm joining new teams every 6 months. So every 6 months, I'm the new kid on the team. But really, dig into those acronyms. It's like speaking a foreign language. You got to get into the acronyms. You got to get into, what is the history of the team? Who are all these people? How do all these people interact with each other? And those are the kind of skills that you're going to learn outside the classroom at Rice. Those are the kind of skills that you're going to learn. How do I convince administration to let me do this thing, right? Those are the kind of skills that are going to benefit you a lot more past those first, 6 months. So absolutely do, get good grades, all that kind of stuff. That's going to get your foot in the door. But beyond that foot in the door aspect, you want to learn how to build credibility, how to make a name for yourself other than just, look at my resume, I'm really good. No, you want to say, oh, hey, I've got a problem, I want to go to Gigi, right? She's going to solve this problem. She's going to do it right. She's going to do it on time, and I trust her. So really learn how to kind of build those skills, get a name for yourself outside of, let me hand you my resume, and then you'll be impressed.
Does it sound better, Jeff? Turned off my video.
Yeah, I can hear you good now. We'll see how it goes.
Sorry about that. Yeah, so I'd kind of echo what everyone else is saying. In the real world, projects are a little bit more open-ended than your problem sets and getting like a set defined set of requirements. And so you have to be open to ambiguity and trying new things and learning something that you haven't studied in school. And so, yeah, just participating in different extracurriculars and building those teamwork skills and everything, and just fostering your curiosity would kind of be the most important things when you're looking into entering a new field or entering into the workforce in general, because you do tend to forget a lot of what you learned in the classroom. But there are some things, I actually do use MATLAB quite a bit. So some skills don't go away, and it's good. Like, and you guys would probably use CAD design and things like that. So any of those technical skills like that are really, really useful. But yeah, in terms of these different roles, you need to be open to learning new things consistently and not falling back on what you learned before, or thinking, hey, I can't do this because I haven't studied this. You have to be very open-minded and like open to just doing the research yourself and just diving into it instead of waiting for someone like a teacher or professor to like hold your hand and do it for you. So yeah, so I think that's why the extracurriculars are really, really helpful, because you're kind of figuring out how to do it yourself. So yeah.
All right, awesome. So the next question is kind of switching gears a little bit. But so traditionally at Rice, aerospace career opportunities are very underrepresented on campus career events. So could you all share how you went about finding your full-time positions as well as internships in this aerospace industry that you found while you were at Rice? And do you have any advice for people who are currently looking for jobs and internships in aerospace?
Do you guys want to go first this time?
No, we're engineers, but we do things the same way every time. All right, I'll go first. So I ended up finding my internships. So I was also president of ASME, the American Society of Mechanical Engineers, which if any of you guys are mechanical engineers, I highly recommend joining, all that kind of stuff. And we really made it a big mission of ASME to be able to send people to different groups or research, different research symposiums, and particularly these large career fairs. So I ended up finding my job with SWISE, Society of Women Engineers, and I was really, really impressed with the way that some of these conferences are run. So obviously a huge topic right now is things like diversity, racial equity, that kind of thing. And so companies like Boeing do tend to only go to a limited number of campuses, just because it's a lot easier to go into A&M and have offers for 10 people at A&M as opposed to coming to Rice, and you have less people that are going to be looking at it. I think that's wrong. I think that you can get some really high quality engineers from Rice. However, that is kind of the business model is, okay, from a cost benefit perspective, how do we really look for getting the most engineers that we're looking for at a particular site. So I ended up getting mine through SWISE. That being said, if you don't fit in one of those conferences, or for whatever reason, I mean, it's not a secret, Boeing's not doing hot right now. So we're tending not to hire a lot of people at this particular moment. And that's, I mean, there's all kinds of things. The airline industry as a whole is just tragically in such bad shape. And so what I want to just let you guys know is that there's a lot of impression at Rice, particularly among, I think this is something that tends to be more of our generation, is this idea that you have to have your dream job right out of college. And what I mean by that is that there are so many people I come across at Boeing that are like, yeah, I worked for a small, microchip manufacturing company for 2 years, and then I came and joined Boeing. Or, I went and got experience in design in, some smaller company or a different company, and I ended up coming through Boeing. So while I highly recommend everyone apply for Boeing and stuff like that, sometimes, things just don't work out, or, there's things outside your control. I mean, COVID is dramatically impacting. I mean, obviously the 737 MAX is impacting us, but not nearly to the point that the pandemic is. And that's really affecting our hiring policies right now. So what I want to encourage you guys is, look, if you come out of Rice and you have a job that is maybe not your dream job, but you think you're going to get good experience. Just like what we were saying with those kind of transferable skills, right? The kind of things you did in your extracurriculars, you can still take those opportunities and jobs, and you can transfer into something else later. So that's, I guess that's kind of my advice for you, is definitely go to these conferences, particularly if you can, I know there's various groups at Rice that will pay for them to send you out there. However, if for whatever reason you don't get your dream job, or you come out and it's your senior year, I mean, I know the job market's really tough right now. Don't think that that's doors closed to you forever. It's just closed to you right now. And 100%, aerospace tends, defense tends to be high spending, low spending, high spending, low spending. So sometimes they'll hit, high points and there's so much money and they're trying to hire a bunch of people. And then sometimes you hit the low points and they're not hiring as many people, or unfortunately laying people off. So what I want to kind of encourage you guys to do is, absolutely go to these conferences, but keep your network open. I mean, obviously the three of us are willing to resource. I can't hire or fire anyone right now, so if you have any questions, feel free to reach out. I have zero power in the company. I mean, I'll know some stuff as far as job opportunities and stuff like that, but I can't hire or fire you. But it is helpful to, when you're doing things like mentoring, you want to make sure you're keeping mentors open. That's not just a, hey mentor, can you get me a job? And more of, hey mentor, can you introduce me to someone who I can talk to who might know of something in the field that I'm looking for? So I guess that's kind of my job advice.
Yeah, if I was to, and this is something that I try to tell as many students as possible, I have two things that I think every single engineering student, particularly those that want to go into aerospace, needs to do consistently the entire time they're at Rice, or at least start now. Go to conferences and network with everyone you meet. Those are huge. Honestly, it blows my mind that some engineering students at Rice still either don't know about conferences or just haven't been really interested in one. Conferences are huge, especially if you want to go into aerospace, because I mean, like Jeff was saying, aerospace companies don't really come that much to Rice. And I know, and that's one of the big reasons why SEDS has tried so hard over the past couple of years to get aerospace companies to actually come. And that's the first reason why I joined SEDS in the first place, is because that was the mission and I believed in that mission. But it's an ongoing fight, right? We have the Owls in Space Symposium once a year, which is fantastic event. Go to that event if it is able to happen this year. But beyond that, there's not much visibility. There's also Native Networking next week. Go to that as well. Anyway, sorry. I don't know why I'm plugging things. I'm not even a Rice anymore. Conferences are huge. I went to two conferences during my time at Rice. I wish I'd gone all 4 years, honestly. They are fantastic. I know, there's HENEC, which is usually the first one per semester. That one, I don't know if it's still open. I don't know if it's happened yet. Usually it's pretty early in the semester. Another big one, SHIP National Conference. That one usually happens in November. Gigi was just talking about the, I think, SWISE. There's a good number of them throughout. And those are some of the bigger conferences that, there's organizations at Rice that will literally pay to send students there because that's part of their missions, talk to SHIP, talk to ASME. And I'm sure there's plenty of other organizations as well. Yeah, Ryan's dropping some good details. Ryan knows pretty much everything there is to know about conferences because he sends people to them all the time. Or at least encourages people to do so. But the conferences are huge. I mean, literally, it's an entire set of time in which you're dedicated to just focusing on talking to people and getting a job. Now, I did not get my job through a conference because during the time that I was going to conferences, I was not a citizen of the US yet. So it's a little more difficult if you want to get into aerospace because usually they're trying to get either, citizens that will be able to classify for security clearance, or at least citizens just because it's easier to deal with any sort of government and federal contracts if you're already a citizen of the country. But regardless, I still loved conferences because it did the one thing that I needed practice on. Networking with people that I don't know, talking to companies that I would have never gotten the chance to talk to, getting to meet a bunch. I met a bunch of different students from other colleges that are all passionate about the same things that I am. And actually, you know, I still keep in touch with a couple of them through LinkedIn. One of them recently started working at Raytheon, and he's an awesome guy. And like, you just get to meet people and network, and you get to practice doing that actual, you know, elevator pitch. You get to actually build your resume well. You get to have it reviewed by countless of people. You get to do a bunch of interviews. It's literally an entire like few days worth of just practice, getting to know people, getting to talk to these awesome companies. And you know, right now it's virtual. Pretty much everything is going virtual. I know SHIP National Conference is going to be virtual. I know HENAC, or you know, Great Minds in STEM is also how it's known, is also virtual. But if anything, I feel like it's still plenty good experience. It means that now you don't have to fly to a different city to go to one of these things. So take advantage. If the opportunity is there, take advantage and at least try it out. You know, I'm not promising you're going to get a job out of it, but it's awesome to get the experience there. So conferences, I keep throwing that at everyone. My little brother just started college as engineering, and I've been telling him right now, hey, go find the organizations that will send you to a conference. Go, go, go. Because I wish someone had told me that when I was starting off freshman year. And the second thing is just networking. You know, there's a lot of people, even sometimes you think, okay, I got to network with people that are like managers or like, you know, these big professors that are connected or whatever. No, literally network with people around you, you know. Oh, hey, there's an upperclassman and I'm an underclassman. Go talk to them, get to know them. I got this job, well, not exclusively because of this reason, but I got a referral for this job by one of my old mentors and an honestly pretty good friend. His name's Sam Zurich. He was the Rice Eclipse president for 2 years. And, you know, I got to be in a mentorship with him through ASME, and then we just became friends and we kept in touch. And one time, just out of nowhere, he dropped a message on Slack, on the Rice Eclipse Slack, and just said, yo, there's some openings where I'm working. If anyone wants to be referred to them, you know, no promises, but I can at least get you the referral. Next thing I know, we were sitting in a call, reviewing my resume, reviewing my cover letter. I sent it in, got the interview, and then got the job the next day. So even though that wasn't like, it's not like he gave me the job himself, I got to hear about the job in the first place because I at least knew him, and he was willing to talk to me because he liked me, and because he knew that I'd put in good work whenever he was around. So it's simple things like that. You know, you don't think the person that sits next to you in class is gonna like have some hotshot job later in life, but maybe he will, maybe she will, maybe they all will. I don't know. So just, you know, being used to just, and again, it's like Gigi said, you don't want to just ask people for jobs. Like that's not effective networking. But building a relationship with people that you respect, people that you maybe have seen put in good work, people, especially people that you feel have similar interests and passions to you, that's huge. That's huge. And keeping in touch with them is also huge as well. So yeah, so conferences and networking, that's what I got for you. And I think anyone who does those two things is going to have a great time getting a job in the future.
Okay. So yeah, you guys covered conferences pretty well. And I actually never went to a conference when I was an undergrad, but started going to conferences once I started working. And I agree that those are a great place to get hired. But while you're at Rice, you can also, like I knew about the Pathways program through one of my professors. And so building a good relationship with your professors is really important. And just being open, just keeping track of all those listservs and all those opportunities and applying for internships. Internships are the easiest way to get a job because they already know you, they've seen your work, and they trust you. So getting an internship where you want to work is really, really key. But yeah, as the others said, like if you start somewhere else and you want to hop ship and go to a different company, you definitely can. It's just good to get experience in what you want to do and get those transferable skills. And then outside of that, the career fair is also very helpful, and career services at Rice are also very helpful. I remember before my interview for NASA, I went there to do a mock interview, and they help you prepare really well. They help you anticipate what questions and how you're going to answer them. They help you with your resume. So, and then they kind of also try to help you tailor your career and figure out what companies match your interests. So taking advantage of all the services that Rice offers is really, really important. And then in terms of if you want a job at NASA, just keeping track of the deadlines for Pathways program or USRA internships is very key. We have internships every semester, and so it's not just limited to the summer. I know that's kind of hard at Rice because our schedules are it's very four-year based, but that's one option. And then for NASA, if you don't get in as a civil servant, you can also work there as a contractor, and Jacobs is one of the biggest contractors for NASA, and just looking up jobs there is really good. So that would be my advice.
We had a question come in on the chat, sort of for everyone. What are some opportunities for international students or internationals in the U.S. space industry? Alejandro, you might be able to speak to that best, but anyone who has anything to add to that?
Yeah, I've had a number of conversations with people on this subject, both while I was in college and even recently. I mean, to be blunt with you, it's not an easy thing to do. I was lucky that I at least was already a permanent resident. I've been a permanent resident of the US for about, 5 years, because that was a requirement until I became citizen. But I have seen a lot of people struggle, especially if you're here, if you're an international student and you don't have what they consider a US person status under ITAR. And I would highly recommend, if you are an international student, look up ITAR, and you can kind of see what exactly some of the regulations are behind some of that work. So it fluctuates a lot. There are space jobs out there that don't require citizenship. I have one right now. My right now does not require citizenship because I'm not required to have a security clearance. They're not super prevalent. A lot of jobs in space particularly do have, yeah, thanks for that definition, Gigi. A lot of these kinds of jobs do require some sort of at least US person status, just because these are direct contracts from the government, right? So if you're working on space stuff, those are all pretty much funneled through NASA, which is a federal institution. If you're working on defense, it's even worse because these are all military contracts. So those are very, very iffy. But again, it's not impossible. What I have been recommending people in the past, if you're an international student, is get involved with research. There's some really cool research happening that is either funded by NASA or funded by space institutions in general, that don't have those kinds of regulations. I remember as I was graduating, Dr. Waymeyer in the mechanical engineering department was getting a huge grant from NASA to do some micro heat transfer research for heat shields for ISS and some other NASA-owned hardware. So research is a really cool place to still be involved in the space industry without having to necessarily be tied under some sort of federally owned contract. So I would highly encourage, find those opportunities, and that can really, really help you get involved in the space industry without necessarily being tied to that. And also, graduate school and getting maybe even a PhD are also things that you might want to consider, just because the longer that you can kind of, still learn and still be involved, while, maybe while you're trying to become a permanent resident or while you're trying to become a citizen, depending on what your situation is, that's a great way to still be engaged. Actually, my plan originally was, well, I'm a permanent resident. I don't have citizenship. My citizenship was originally going to take until mid-2021. So my plan was, okay, that gives me a year and a half until after I graduate. I'll go do grad school. That way I can still continue learning and still grow without necessarily being tied to a specific job. And then after that, I'll apply. I got lucky and my entire process got moved up because we came very clean in our background check and my family got citizenship in July. So it really depends on your situation. Another thing that that I would maybe ask you to consider is, you know, like Gigi was saying earlier, you don't have to start in your dream job from the get-go. That's something that I've actually met people at my job right now who actually, I know one guy, he worked like 20 years in the automotive industry as a mechanical engineer. Obviously, you don't have to do 20 years at whatever job you want, but you know, he was still trying to get his citizenship, and you know, he wasn't sure if he was going to go back to live in his home country or if he wanted to stay. You know, he wasn't sure. So yeah, he ended up just committing, and then eventually he did transfer over. The last bit of advice, and I'll make this briefer, look at private space companies. There's some private space companies out there that are not based in the US. And if that's something that you're open to, that's great. You know, I wish Josh K was here to talk more about it, but no, he worked previously at Rocket Lab. Rocket Lab has a site in New Zealand. Their original site is in New Zealand, which, by the way, awesome country. So working there is not really a problem if you're not a US person. You know, if you want to go on the European side, Airbus is not a private company, and maybe Gigi will get mad because it's directly her competitor, but Airbus is not a US-based company. So you can consider that. So yeah, those are some things that you might want to consider.
On that side, also, if your space is definitely going to be tricky because turns out rockets are very similar to missiles, and missiles tend to be really, classified real quickly. And the biggest hurdle you're going to run into is you cannot get a security clearance unless you're a U.S. citizen, right? So if you're a U.S. person, if you're a foreign national, you cannot get a security clearance. And that's going to be far and away your biggest hurdle. That being said, there's also lots of opportunities in aerospace that are not military based, right? So space is very military adjacent. So you're going to run into a lot of those things. But if you're just interested in aerospace as a whole, tons of research and tons of interesting things going on, you know, and obviously anything commercial. So any kind of commercial planes or stuff like that. Also, lots of people do things for things like Raytheon or BAE or anything like that, where you're going to get that same, you're a sub-supplier, so you're not the final assembly, but you're a sub-supplier, and getting a lot of experience in that. If you are with those companies for a number of years, they'll, they might sponsor you for citizenship or anything like that. So directly getting into space is going to be hard. You are going to have to take a more circuitous path. But that's not to say that it's completely out of the question.
So we're just over 3 o'clock now. So I wanted to ask all the panelists, or if you all need to leave, then that's totally fine. But do you have time for like one more question, like a few more minutes, or if you got to go, it's fine.
Yeah.
All right. So we'll just go through one more question. I think that'll pretty much cover it. Of the projects that you've worked on so far in your career, which projects helped you grow the most as an engineer and why?
Do you mean at Rice or at work?
I would say at work, like in your, as a new engineer.
Okay. Let's see. Well, I've only been working for about 2 months, so give me a break. I'm still getting there. Maybe I haven't grown as much as I will eventually. So I don't really work in what you would consider well, I guess you would kind of consider it a project, but this project has been going for 5 years and it will continue to go for another 5 years. So specifically, I guess what I can kind of talk to more about is more like a specific experience. The reality is, whenever you start off work, people are not going to expect you to immediately be like ready to do everything. So even now, you know, I'm expected to basically still be technically in training for like another 2 months, maybe, before I actually get to technically own a product. Manufacturing engineers are usually known as like the technical owners of specific products. So we own all the processes that happen on a specific piece of hardware. What happened once, this actually happened about 2 weeks ago, is every other manufacturing engineer in my office had to do this like mandatory training in which they'd be gone between like 8 in the morning until 1:30 p.m. And that meant that pretty much the only people in the office to really be able to do anything manufacturing engineering related were myself, the lead engineer, and our manager out of the team of originally like 19 people. So I had to adapt and I had to become a lot more responsive, and I was actually being asked directly, you know, technicians would come to me directly and ask me to do things for them or try to fix things for them or say, hey, this went wrong, what do we do? So I guess I got kind of thrown into the fire. One of the things that I remember the most from my internship last summer, I worked at Honeywell, is failing. And I remember failing at the time because I messed up this one hardware. And I'm so happy that I did fail at that time. Because man, it is so easy to learn from a mistake. Learning from mistakes is probably the best that you can possibly do, particularly when it comes to engineering. Now, luckily, you know, nothing actually went wrong. And luckily, even right now, I'm not given everything that I do is basically checked, right? You know, manufacturing engineers, everything we do is basically checked through quality engineering first before it gets issued to the floor. So we have checks and balances already within the system. But what made me grow the most is I actually messed up once within some of the planning that I wrote for a part. It was caught by quality, thankfully, but they sat down with me and they taught me through it. And it was actually the first time that I got to meet our quality engineering team, because before then I wasn't the one that was sending them the instructions directly. So honestly, sometimes being thrown into the fire, and especially when you do actually mess up, can be terrifying. But I think is by far one of the things that I am now the most open to, just because I've always learned every single time that I've failed at anything. And I feel like that's what ends up making me stronger. You know, that's what makes me a better engineer is, oh, I know what failure looks like. Let me accept the lesson and not dwell on the fact that I messed up. So I think that's huge for any engineer.
Okay. I would also say my first few months at NASA were the biggest time that I learned, just because I was very used to just like finding the perfect answer and like overthinking things and not just trying them. And so that was a big learning curve. And also my mentor at that time was also new to NASA, so we were both learning everything for the first time. So I kind of learned to not just like be dependent on one person, but figure out who to ask questions to and who to go to for different things. And then, yeah, it was all about just learning the people of the place, like learning, same as Alejandro said, like when he met the quality engineers, he was able to make that connection and learn from his mistakes. I also did a bunch of CAD designs and they weren't very manufacturable, so I sat down with the people in the machine shop and they kind of guided me through some of the little mistakes. But yeah, just being open to making mistakes and learning, and people are very willing to help you and teach you, and just asking good questions. So yeah, I think the first time you do anything, it's always going to be tough, and that's when you're going to grow the most. So just not being scared of it and not being scared of looking like you don't know what you're doing, because that's what they expect. Like, they don't expect you to know everything the first day of your job. But as long as you have a good attitude and you put in the work to learn, people are very forgiving. You know, they've all been there. Everyone understands that feeling. So yeah, just being open about it, I think, is a good strategy.
Gigi, anything to add here?
Yeah, I had some technical issues, so I had to call in. No, I mean, I think they pretty much covered a lot of things. I think definitely, particularly coming out of Rice, I know that I personally had to learn a lot of humility in that first job. And what I mean by humility is you don't know everything and you don't even know what you don't know. So you kind of have to figure out really learning that unknown horizon. And what I mean by that is, where does what you don't know overlap with what other people don't know, right? So finding out where is that spot where nobody knows the answer, and really trying to, the sooner you can figure out that area, the sooner you can kind of be effective on the team, or the sooner you can kind of actually contribute to the team. Because the further you push that horizon out, the more you know and the better you can do engineering. So really learning, hey, coming in and saying, hey, look, I'm a new engineer, recognizing that and saying you're not expected to come in and know everything, which I think the other two pretty much covered a lot of. So.
All right. Well, I think we're about in an hour now. So thanks so much to all of our panelists for taking the time today to come speak with us. I know I learned a lot from this. I hope everyone in the audience learned something too. So we really appreciate your time. Thank you for coming to speak with us again. Did you all have any last things you wanted to, last bits of advice, or just things we didn't get to that you wanted to get out real quick for everyone? Or with that, we could also call it a wrap here.
Yeah, I mean, this is a lot of fun. Thanks for thinking of me whenever you were setting this thing up. I always love talking to students. So yeah, thank you all for coming. If any of you want to connect, I know I love to connect with students, particularly, especially if you're a freshman or a sophomore. You probably have the most questions that I have already answered a lot before. So it's very easy for me to be like, oh, cool, I know how to do that thing. I do a lot of resume work. I do a lot of cover letter work. If you want to talk about any of that stuff, hit me up. And yeah, I'm just like slowly trying to transfer into like that alum that kind of bothers people, but is also just kind of poking at you to say like, hey, I'm here to help if you want it, I'm here. Hey, how's it going? So yeah, take advantage of me. Thanks, Jonathan.
Yeah, I think Alejandro kind of mentioned this, or we mentioned it earlier, but like particularly alumni, we're kind of in that alumni position where we might know jobs that are out there, right? So I know that they're, hiring a bunch of people in St. Louis right now, and I know that there's a bunch of, job recs open. So things, if you're like, hey, I really want to join Boeing, but I don't know where they're hiring, even just knowing someone who's familiar with the company and can say, hey, there's a lot of internal recs that are not publicly available, right? If you Google Boeing jobs, you aren't going to see these. So having that kind of opportunity or that kind of connection, but also this is completely low pressure. I mean, I only graduated a year and a half ago, so I completely understand where people are coming from. I'm not going to prevent you from getting hired at a place, and I might not be able to help you get hired at a place. But I also do, I've done a number of interviews for Boeing, so I kind of know, okay, what is their format? I know what they're looking for on resumes. I must have reviewed probably over 100 resumes my senior year as president of ASME. So like things like resume reviews are absolutely, you should totally hit up some of our experience on that. Interview questions. What kind of things are people really going to care about, or what things are people are not? I would say I'm also very familiar with the general aerospace field. So if you're like, man, I really want to do aerospace, but I don't know what the difference between Lockheed Martin and Northrop Grumman and Boeing are, things like that are always good topics to talk to about mentors. We're here, we want to see you succeed. You're really not going to be bothering any of us. The worst thing that we could say is no, right? So if you say, hey, Gigi, can I have, half an hour of your time? Yeah, sure, why not? I've got plenty of time. So please reach out. I mentored probably 7 different interns this summer, so it's not something that's outside the scope of what I've done before.
And yeah, same, feel free to reach out to me too. We've all been where you are, and we really want to help you succeed, and that's our goal. So yeah, don't feel like you're a bother. And for life advice, or yeah, like if you're starting a new position, really want to help you guys succeed and just get the positions you want. Same as the other people were mentioning, it's hard to have hiring power, but we definitely have been through the process and can help guide you through that.
All right, well, thanks again so much, everyone. And I think that's going to be it for today. So thank you all. Do you have any closing words, Ryan, or is that a wrap?
No, just thanks everyone for coming out. Thanks to all the students. Thanks to all of our panelists. I also learned a great deal today, and nice to see some familiar faces today. Thanks, everyone. And remember to sign up for Night of Networking if you haven't already. There's about 15 or 16 aerospace companies and 36 companies total. So definitely check it out.
All right, well, thanks, everyone. Have a good weekend.